Today, I'm talking with Amru Atassi, an expert in protecting public health through drinking water treatment. Amru's based in Chicago, and he's been working closely with cities and water utilities across the Midwest US to battle the critical challenge of lead in drinking water. Amru's worked on all phases of water treatment projects, and he's helped lead a number of Water Research Foundation R&D efforts for lead and copper corrosion control, bench scale testing, and pipe loop design. And it's pipe loops and pipe loop studies that I wanted to ask him more about today. Amru, thank you so much for being with me today.
Very happy to be with you, Andrew.
Let's start with just some basic definitions. When we talk about corrosion control in a drinking water context, what exactly does that mean?
So corrosion control in drinking water, we're talking about controlling the corrosion of lead, copper, iron, and other pipes that are in the distribution system. Lately, the focus has been on lead with the changes to the lead and copper rule and controlling the corrosion of lead that may impact lead levels out in drinking water.
So the EPA is actively revising the lead and copper rule, and the expectation is that when those revisions are officially promulgated, that pipe loop testing will be required before a water utility changes its corrosion control treatment. So why do you think EPA sees that as a critical step? What's the benefit of pipe loop testing?
Yeah, so the regulations as they stand right now, the lead and copper rule revisions do require utilities that have lead service lines to do pipe loops with harvested lead. These are lead pipes that have been there for years, and they want to use that as the basis of testing. And pipe loops allows us to take the finished water that's going to go out in the distribution system that's in contact with those lead pipes and run that experiment as a real world condition. And so that we can simulate different treatment process changes, corrosion control treatment options, and the impact of those changes on reducing lead levels with those pipe loops.
So this is a really realistic test to see how the actual treated water and the actual pipes will interact. You're actually harvesting real pipes from the ground, from the system, and using those in the test, right?
That's exactly correct. So the harvesting process is a very important process because you have to be very careful with those pipes. The scale that's inside the lead service lines. I have actually a cross section cut here of a pipe, and you can see the inside, the scale that's formed over the years. So there's a lot of history inside that scale, and capturing that in a pipe loop experiment is going to be very important because that's not something that you would get out of a brand new piece of pipe.
So to take one high profile example, had there been a pipe loop study before Flint's drinking water source was switched to the Flint River, what might have played out differently if they had taken that approach?
It's a question that many experts have asked because certainly it would have revealed the impact of the source water change on those lead levels, because you'd have side-by-side pipe loops, one with the treatment process that existed at the time and the source water that existed at the time, with right next to it a pipe loop with the change in source water. You would have been able to compare those lead levels side by side and see are lead levels less or worse. In their particular case, we know the water was much more corrosive, and as a result, the pipe loop experiment would have yielded that lead levels are higher with the source water change. It would have basically required the decision makers at the time to rethink this change.
How long do these tests generally take? How long do you run the study for?
So typically, once a pipe loop skid is built, and you have the harvested pipes, whether it's lead or other materials, are built on the skid, we usually let water continuously running through these so that these lead pipes or other materials are reconditioned, right? Because they've been removed from the ground, the scale may have dried a little bit. So you want to rebuild that scale. And that conditioning process depends on a lot of variable. That really drives the testing duration, right? If you need an extended period of time to condition these, that's going to prolong the testing process. So careful harvesting is gonna help in not needing to condition these for as long. Once the pipe loops are conditioned and you're able to see that all the lead pieces or other materials are behaving consistently, and that they've stabilized, we can go into a typically a year-long testing process. And the reason it's a year specifically for surface water is surface water has the variability of temperature fluctuations, other water quality fluctuations. Groundwater typically is consistent year round. There are obviously a few exceptions, but generally speaking, surface water you would need a year-long process after the conditioning. So generally, from after they're built, it could take 18 to 20 months total to get good results that you can rely on to draw conclusions and recommendations to help a water utility.
Well, Amru, this has been fascinating. Thank you for letting me into the world of pipe loop testing. I appreciate it.
Thank you so much for the opportunity. Glad to be with you today, Andrew. Thank you.
Water utility leaders, is your system ready to meet the forthcoming lead and copper rule revisions from EPA? CDM Smith has put together a readiness compliance checklist that lists everything you need to do to prepare. So hit the link below to download it and get your organization on track.